Hello again. Now we're in the Good to Know video. So here I've collected a few tricks or tips that I learned over time that allowed me to reduce my stress. I may not have said this before in a different video, but there's just so many things you could possibly learn in software. And as it turns out, my personality style is flawed in a way because once I find the tools I need to do what I need to do, I tend to stop looking around for other techniques and just go with it. Sometimes this is fine, but sometimes I miss tools or commands or whatever that could have greatly simplified my life. And so one of these tools, actually a few of these fall into this category, where I found out about these things in my very last project in my 20th year working in software. I have no idea how long they've been there, but if I'd known these years ago, it would have been a lot of stress reduced. And the reason I say it's a lot of stress reduced is because some of these things are ways to make it so that you only have to type one command instead of a whole bunch of commands. And I articulated for myself a few years ago, I was trying to figure out what was so stressful about the last deadline. And it occurred to me when I thought back to 11:59 p.m., what my life was like. I was frantically typing command after command after command. And I realized I didn't have enough automation. Really, what I should have been doing in an hour is typing maybe 50 commands rather than 300 commands. And so I began to realize, okay, I need to boost up my automation game and make it so I can run commands that do all the dirty work. And I don't have to think so fast about what I need to do. And so that's kind of the spirit of at least some of these tips. So let's dive in. So this first one, this is an SSH config file. First of all of the files I'm going to show you here are in the bundle. So you can just copy them out of there and modify them and use them if you want. So the first one is an SSH config file. So this would live under your home directory /.ssh/config. And so up here on the left, this bit of syntax here defines a host with that nickname. It has the IP address right here and a private key that's referenced. And this is the username on the machine that I'm logging into. In this particular instance, this machine was provided by another group, and they just made the account. They called the account Ubuntu, just to be simple. And port 22, forward x11 yes, forward agent yes. So when this file is in play, when this SSH configuration is in play, and I just type SSH space EC2A, it'll just connect me to that machine. So I don't have to type anything longer than that. That's a nice little bit of support there. But the real gold came in this part here. So we have a nickname Flip, which is what I'm calling the access ENGR OregonState.edu host. Now, depending on when you're watching this video, maybe the name of this host has changed. Maybe the year is 2729 or something, and it's a different host name. But let's just say this is the standard access host to get into the OSU landscape. And I have my username here. But then we have this proxy jump command. And so if I type SSH DGX, what it's going to do, it's going to first connect to Flip, and then it's going to connect to this host. So I think I have a little errant key there. Fix that, so it cause confusion. And now here we have this is one of the submit hosts for the cluster. And so If I ultimately want to get to one of the cluster machines, you may know that I first need to connect to a submit host. And now here's the name as of this writing, or whenever I was using this. I know they changed the naming schemes periodically, but let's just say there's a DGX21 host, or this is my nickname for it. This is the formal nickname for it. And then I'm going to proxy jump from here. So basically, if I just type SSH DGX21, it's going to connect me to the access, jump me over to the submit host, and then connect me into the cluster machine that I want to get to. I don't always work with the cluster, but there were a few projects where I did, and I would connect and connect and connect every time, never stopping to ask myself or ask anybody, is there a better way? So that was just awesome to learn that. Okay, here's something else this is pretty esoteric, but just in case you need to know it, this is something we figured out in our most recent project. We were using software provided by a different organization. They were part of the research team. They were the evaluators, but we had to run our stuff inside their framework. We had to invoke their controller. And so their controller at runtime was installed as a Python library. But they had a timeout setting that we needed to change, because in our environment, that timeout was way too long, I think. And we needed to, no, it was way too short. And we needed to lengthen it, I think, if I'm getting that right. One way or the other. We needed to change the timeout. So I figured out a way to patch it. And so this file is just a little code that I'm not going to bother going through this too much, but basically we had 3 different projects, 3 different sub-projects, and each one used maybe, I think 2 of them used Python 3.7, one of them used 3.9, and that's why I had this divided up into 3 types. Oh yeah, okay, so here's the key. So when you invoke that and you give a number of minutes, it will change the timeout to that number of minutes. I'll let you look through there to see how that works, but it is possible to patch and install library Python. It's something you don't want to do every day, and you want to be very careful. But if you are in a bind, you can do it. Okay, aliases. Probably everybody knows about aliases, but just in case, before I knew about the proxy jump trick with SSH, I was using aliases to connect to these machines. And so in this bash script, I had this alias would connect using SSH to that machine, had 3 different machines. And with this, once I ran this script, I could just say E2A return, and it would connect. Now, one reason I wanted to show this is because I have this print statement here that serves as a reminder just in case I forgot. When you run a bash script, the default behavior is any environment variables, any aliases you set up inside the script disappear when the script is done. They're there just for the duration of the script. If you want to set some stuff up and have it survive, you have to use this different syntax. You have to invoke it with ./name of script.sh. That way, when the script is done, the calling environment inherits those settings. So just wanted you to know that. All right, what's my next one here? Run remote commands, SSH. Okay, so again, this was something I learned very recently. And when I did, it opened up a whole bunch of potential landscape for automation, which I took advantage of. And I did some really cool things. Somehow I got to age 61 before I learned that you could use SSH to run commands remotely, any number of commands. Simple me, I just thought SSH was for making connections that you could then type commands into. But no, it's more flexible than that. Now, SSH here also lets you invoke a command. And so in this case, it's the move command. So it's a remote, I'm calling it remote move file. Nothing too fancy there. But you can also do multiple commands. You just have to put them inside quote marks. Where's the quote mark? Here it is. So these bunch of commands together, I can set some environment variables, and then I can, semicolon cd to a particular directory, and then run this command. In this case, we redirect it to an output file, and then I use scp to drag that back. I think there might be a more efficient way to do that with SSH, just catching the output, but I left it like this. I can't remember why. But anyway, so with this technique, if I had data on another machine and I want to run stuff on my machine and grab data off that machine, well, this allowed me to do this in Python very easily. And let's see, what else we got here? Killing zombie processes. So on our project, most recently, we did a lot of stuff on GPUs. And if I was running my system and I hit Control-C, sometimes the zombie processes would still be running on the GPU, kind of silently there. And so they'd be using up memory on the GPU that would cause problems later when we try to run the next time. And so have this code here. You can read through it yourself that shows how I made basically a zombie killing command that was pretty flexible for looking for stuff that was running based on, or stuff that matched commands that I had run. So here, let's see. I'll just, rather than being too abstract, I start with stop processes, and then I'm going to kill optics processes for the command run scenes. Then I'm going to kill the systest scene runner, and kill optics procs for command manager. And so when I go for the, just down a little bit of the details here, I just have this huge PS pipe grep, narrowing down what I'm searching for through the process list. And depending on what I find, get a list of processes, maybe do some verification that things look right, and then I kill those processes automatically. You may benefit from that. I think there's one other thing that I wanted to say. Okay, a minute ago, when I talked about using SSH to do things, one of the things pretty cool that I did, I had kind of a data stored on a remote machine that our evaluation team had set up for us. And it was all the centralized test results for a distributed testing system that I wrote that allowed everybody to run tests, and all the information was centralized on this one remote machine. So I wanted to write a little web app to review those results, but I didn't want to run a web app on that remote machine for security reasons. And I didn't want to bother with making it so the web app, you needed to make an account and all that stuff. And so what I realized I could do, I wrote a Flask app, Flask is a library in Python for writing pretty simple web apps. Wrote a Flask app, but rather than having it communicate with HTTP, the back end, I basically had the Flask app running on a local machine, on my laptop, for example, and the logic behind it was using SSH commands and SCP commands to get the stuff from the other machine. That meant as long as I was authenticated into my laptop, that's all the authentication that needed to happen, because this SSH conversation was using the public private key stuff. So once I realized I could do that, that was pretty awesome because everybody in the team could run my app, but it was all running on machines they were already authenticated into. Pretty cool. All right, I think that's covers all my little good to know things. Hopefully some of that was useful.